Enumerations are very useful if we work with restricted set of values, and in Swift enums are more advanced than other languages. For instance, enumerations can have methods associated with them or properties, but on computed properties, and we can associate data with any case in enum. Here we can see a basic example of enum, this classical one, let's say. Actually, this is not that useful as it could be. In Swift, enum is much more powerful. Here is just example. We declare some variable with this enum data type, and we assign value, this case completed. Actually, we cannot read too much, as we can see. However, in Swift, we can also assign another type to enumeration. Can be string, double, whatever, basically. In this example here, we assign string data type to enum, and it's the same enum, but this one is more powerful because now we can use raw value to get some description for every case. As we can see here, we have access with dot operator to inside the enum, to cases in enum, and if you would like to have description for completed, this value for completed, we can get it with raw value, as we can see here. Oh, sorry, this one. This is exactly this line. Yes, completed. Order status raw, completed, raw value, and we can straight away get something printable, so we can read it. This is more useful. The other data type could be integer, for instance. As we can see, we can assign value for every case which is of this data type, and we can have computed properties, as I explained previously, only computed properties. And property like this one, for instance, is useful if you would like to get some description for every case in our enum. We can call this property. Just below here we have some method, because enum in Swift can have method. This is very primitive, just to show that it can exist. And let's say we have the status, order status, which is this enum, is cancelled, and now we would like to use this computed property to read something for one of our cases. This is for cancelled. So thanks to this computed property, we can get some description, some information which is possible to print out on screen and use it later. This is just calling to retain status to our method in enum. It just print out some information, return pending. There is nothing more. We assign it to constant, the status, which is defined previously. The status, yes, this is the same one, and we call now our method, and the only job is it returns some string, and we print the string here. We can assign values to our cases, as in example here for enum order, can be integer, double, string, or tuple, whatever, and we could define the value for every of our case using some kind of method like this one, where we use switch, and self is just for referring to our enum inside. For case first, we have integer, so we will return integer. Next will be double and string. We can describe obviously all of them. We have to do it, and we basically have, as I said, we have to do it. So if we have 3 cases, we have to describe everything. If we don't want all cases, we can use default, and we'll return just default value for whatever else except what is described above. In this example here, we have variable for enum, and we assign case with associated value 5. This is integer, because for case 1 we can associate integer. We repeat the same thing for the same variable, but now we change it, and for case 2 we will assign double, because this is what we declared here. And we can print using method return value. So for our variable we will get double is 5.9, because it's the last line, the last value we described for variable a in this point. And obviously we can use enums for arrays. We can make decision that the values in our array will be of this data type enum. It's basically the best way to see how advanced are the enumerations is to use them in some application, but as we can see, this is just part of the possibilities, small part of the possibilities for enum, and it's definitely much more powerful and useful than in Swift than in other languages.